Good morning. Welcome to the first segment of section 1.1. This is really the formal beginning of the course material. So I want to give just a sort of a brief overview of how these recordings will work. I've uploaded all of them to YouTube, which allows for closed captioning, which is usually pretty good, but it seems to be the best format for students to interact with the material. So there's that on the upfront side. But from a mathematical standpoint, as to what we're going to try to execute throughout this course, is there is an expectation that a student taking trigonometry has had not only an experience in college algebra and probably several years in algebra, but on top of that has also at some point taken a course in geometry. Because trigonometry seems to be the union of those two different mathematical types, algebra and geometry. Now, often what I experience in my classes, I will usually do a little survey at the beginning of the course and ask students how many people have actually had any kind of experience with trigonometry at all, which is, maybe some things like measurements of sides of triangles and solving triangular solutions and that sort of thing. And usually what I find is that almost everyone has had a geometry class, but it may have been several years ago. Usually around 60 to 75% of the students will say that they've had some experience with trigonometry as well. And so what I'm going to try to do here at the very beginning is try to give a very precise introduction that starts with geometry and leads us up to some of the basic fundamentals of solving triangles and triangular relationships, culminating with two things. One is we will develop the Pythagorean theorem from basic principles, and we will also state some obvious, well, not necessarily obvious, but some geometric theorems and their results, and apply them to triangles. Fundamentally, this class is about the study of six functions, the basic six trigonometric functions, not necessarily about solving problems, although that is certainly an aspect of it. And as we move through the course, what you will find is that some of this stuff is more applicable and some of this stuff is more theoretical, depending on what your overall plan is here at the college, what degree you're pursuing or what courses you might take. Almost exclusively, trigonometry is a prerequisite for something else. Generally, that's either a physics course, some sort of an applied statics course, a calculus course, or maybe a combination of all those. So bearing that in mind, I will try to draw out the material that is relevant to those other courses as it becomes, as the topic comes up. Personally, myself, I spent 12 years as a land surveyor before I started teaching, and use trigonometry on an almost daily basis. So I can say with some authority that this is not a purely abstract or mathematically insignificant kind of study. In fact, trigonometry is the lead-in to a much larger world. Prior to it having a trigonometry class, your ability to understand the mechanisms that make up the relationship between physical properties and the larger world are limited to one dimension. And obviously, we don't live in a one-dimensional world. So to be able to move to that next state, it becomes fundamental to have a good understanding of trigonometry. Now, you don't necessarily have to be a complete whiz when it comes to proofs and that sort of thing, although we'll see some of that. But you do have to have a solid enough understanding of those six basic functions in order to be able to use them in applications minimally. And when you get to calculus, if that's where you're headed, there are some unique properties about how these trigonometric functions are related to each other that allow you to solve more complicated problems. So that's my sort of entry speech about the importance and what the fundamentals of this class are. In order to catch up wherever people might be, I'm going to start with a pretty basic review of geometry, and I will try to be very precise, because it may be your experiences You maybe have never taken a class from a professional mathematician, which I am, and I'm going to try to set the stage for the kinds of mathematical experiences you will have in the future. It is not just about utility, it is also about precision, logic, and execution that is really the hallmark of mathematics that makes it different than an applied science or something along those lines. So in order to get a real solid foundation, this may seem a little bit theoretical, but eventually we'll get to something that's fairly useful. As I create these lectures, what I will do is I will side by side, I have a document camera and I will write stuff as if I was on a blackboard or whiteboard in a classroom. And then those notes will be made available in the section that you'll find on Blackboard. So I'll be keeping a record. You can take your own notes, certainly, because I will say some things that are maybe above and beyond what's simply written, but there's maybe no need to do that. You may want to print them off or just have them available as you watch these videos. It is certainly, other students have said that that's been helpful. So without any further ado, I'm going to kick it over here to the document camera, and we'll start on some very basic definitions of things that you probably should already kind of know what they are, but maybe don't have a precise relationship between these things. So, this is going to seem really, really basic from where we start, but oh, I think my pen, there we go. So this is section 1.1, page 1. So I'm going to start with some basic geometry, and this will seem very, very basic. So one thing that you'll find in mathematics is that things are defined very precisely, and then the integral results between those things is used to construct proofs of properties that maybe are not intuitive from the very beginning. And I am going to switch out to another pen. I think this one is just completely dried out. So the first thing I'm going to do is I'm going to define half a dozen different terms, and then also some concepts as well. So the first one is we have to think about, in an abstract sense, what it means, what a point is. Now, in mathematical systems, there are always going to be some terms that are not definable. In fact, they are intentionally undefined because they have utility in a lot of different ways. But I think for our purposes, it is sufficient to think of a point as just exactly what you think it is. Some coordinate on a coordinate system, be it 2-dimensional, 3-dimensional, whatever, 10-dimensional, infinite dimensional, whatever. But that is a good enough idea of what a point is for the purposes of this course. In a rigorous mathematical, like a non-Euclidean geometry class, you would actually define them as just elements of a set and then leave it at that. But anyway, so if we start here, we're going to define a couple of ideas, and as I define them, I'll underline them so you're clear what the term is being used. So 2 distinct points. Now, what does that word mean? Oh, sorry, A and B. Okay, so 2 distinct. Distinct means that they are not equal. They are not the exact same point. So that's a term that comes up frequently, but you have to sort of keep this careful language in place, because if we start saying, well, maybe they're not distinct, maybe A and B are equal to each other or whatever else, you end up with some problems. So I'm trying to be real careful with the words. So 2 distinct points, A and B, determine a line. And I will actually say this, a unique line. Now, what does that say? Well, what that's saying is if you've got 2 points, there's one and only one line that goes through both of them. That's sort of a hallmark of what's called coincidence geometry. And without it, you have a lot of problems trying to expand this beyond just a flat plane. So continuing, all those points between A and B including A and B determine a line segment. Now, I don't want you to walk away from this. Sometimes the word that's used, sometimes simply a segment. So I don't want you to walk away from this thinking that we're talking about something that's extraordinarily bizarre, because we're not. We're talking about things that you probably have a lot of familiarity with, but in order to couch them in terms of a higher ordered sort of process, I'm trying to be very careful with the language. So let's talk a little bit about notation. Notation. We won't do a lot of this, but it certainly does come up from time to time. When we're talking about, if we're wanting to name a line, and you can think of it about the, the representation that you're familiar with. Here's maybe say point A and here's point B. All the points that are determined by this line or determined by these 2 points is this line that presumably extends forever. The notation that's used to describe this line is AB with this little hat that has arrows in both directions. And that should be kind of familiar. Now, there could be other names for this line. For example, if there was a point C that was in the middle, or D, or whatever else. But this is a unique line, and it's the only one that passes through A and B by axiom. So this is now if we're only talking about the points between A and B, and not the extension, then the notation is just simply AB with a flat line over the top. And this is probably what we'll use more than this anyways. So I'll just put line, segment. Okay, so to continue, I think you know that there's something else between this, is something called array, where it's sort of extended in one half, halfway forever if you prefer. So a portion, and that's the next thing we'll define, a portion of a line that begins at a point, and we'll just use the same letters, say point A, passes through a point I'll say a distinct point B, and continues is called a ray. Well, in this case, in this particular case, it's ray AB, and the notation for that is AB with a one-way arrow. Now, understand, and sort of as an aside, not equal to BA. And that's kind of somewhat relevant because these two notations for line and segment are interchangeable. If you had A first and then B, or B first then A, it really doesn't make any difference. But when you start talking about array, it does matter, because this starts clearly, as it's stated here, starts at point A, doesn't extend, off in this direction, but does extend off this way. And that's distinctly different than starting at B and going through A. Okay, so again, these are sort of basic concepts that I'm sure you're familiar with, and I'm not trying to be pedantic or anything. It's just we got to start somewhere. So section 1.1, page 2. Okay, so how about an angle? So an angle consists of two rays. With a common endpoint. Or if you prefer, a common starting point, whatever. It's, I'll give you, I think you know exactly what I'm talking about here. The two rays are called the sides of the angle. And the common endpoint is called the vertex. Okay, so this isn't a whole lot to unpack, but I'm going to try to be very thorough here. So basically, what this is saying is if you've got one ray in space and another one that's sort of also connected to it, this might be point A, and maybe this is point B, maybe this is point C. Now in geometry, it doesn't really make any difference which order you work in, but we're going to find very quickly that we need a specific order in order to start making measurements. But in this particular case, what we've got is we have AB together with AC, right? I mean, this is kind of a little bit of interesting sort of set notation, right? Because this symbol represents all the points starting at A, passing through B, and extending onwards. That's a set. And over here, we have the set of all points starting at A, extending through C and onward. And we can make this little equality. We can say, well, the union of ray AB and ray AC is actually the angle BAC, or alternatively, the angle CAB. And this symbol here is what we use to represent an angle. This is not a unique representation. And in fact, you can see right here that it seems to be commutative. It doesn't matter which way we label these, just as long as the vertex is in the middle. And sometimes we will use the simplest notation, which is just angle A, if it's understood exactly what we're talking about. Now, if we need some specifics, then we add the extra letters. Now, in geometry, this is sufficient. Unfortunately, in trigonometry, we need to have sort of a starting point and ending point, and so these two things will not be equal. And so I'll go into that here, and I think I try to keep these videos down to less than 20 minutes. So I probably will define the concept of a measure and something about the sides in probably our next video. So I will see you back here real soon.